Hello dear students, it's software ISIJRF Statistics 2024 and question number 8 comes in. Consider sequence of sine observations of each of the observation is independent generation of the uniform random variable. We define the run as a sequence of the sum integers and this and sequence of this. Find E of Rn. Okay, let's consider xi be the length of the run. Okay. So the run is of k and contributes to 1, so the total number of runs. So since the run is preceded and followed by different integers and no specific integer at all, so the possible number of values of xi's are 1 to dot 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 9. So probability of xi equal to k is equal to 1 by 10, 1 minus 1 by 10 square, 9 by 100, 9 by 10 whole to the power k minus 1. So the expected number of runs in k is, you can take it as E of k nk, given by P of xi equal to k n minus k plus 1. So therefore the expected number of runs E of Rn is given by summation of E of nk. So E of Rn is the summation of this thing n equal to k equal to 1 to n, 9 by 100, 9 by 10 whole to the power k minus 1, n minus k minus 1. So E of Rn is 9 by 100 is out of this, so n minus k plus 1. K minus 1. So E of Rn, a little bit of calculations here you have to do. By 100 n into 1 n by 10 n, the summation of part, and this ddx 0 to n minus 1, 9 by 10 whole to the power k. This directly, and after a little bit of calculation we can reach to this value as 9 by 10 n plus 89 into 9 by 10 whole to the power k. So therefore the expected number of observations is this.